All right, this is the first day of 1.7. We are focusing now on graphing quadratics and using standard form and factored form, okay, to graph quadratic functions. All right, so a couple characteristics of quadratic equations that we need to talk about are if we have a quadratic in standard form and we have these coefficients a, b, and c. Okay, those are the different numbers that we could substitute in there that change the shape of the graph. We want to have a good sense of what they do. Okay, if a is positive or negative, okay, we can lump these two together and describe this as direction. Okay, if a is positive, the graph, which remember is in the shape of a parabola, it opens up. Okay, meaning it looks something like that. Okay? If it's a negative sign, that graph opens down and looks something like that. Okay, so that's really the very first thing you should notice about a quadratic function. Which way does it open? Up or down? Well, look at the sign of that number in front of x squared. Is it positive or negative? This will tell you which way it opens. Okay? Now, how about if it's a fraction or a number greater than 1? This controls the width. If we have a quadratic where a is greater than 1, for example, like 2, 5, 10, or 20.3, any number greater than 1, the graph is skinnier than x squared. Okay, the regular old quadratic graph, x squared, that hasn't been shifted or changed at all, if we were to compare this to that, we would see that its graph is skinnier. Okay, and likewise, if it's a fraction like 1/2 or 1/4, okay, its graph is going to be wider than x squared. All right, so direction and width, those are two big elements of a quadratic graph, and this number here in front of x squared, that's the number that tells us what it's all about. Okay, which way does it open and how wide is the graph? All right, so there's a couple pieces that we're going to look for when we're going to put really sketch kind of the main characteristics of a quadratic graph, which is worth referencing here. Remember, this shape of a graph is called a parabola. Some of the certain points, or some of the specific points that we want to know. Okay, the vertex, which is right down here, that minimum point if we have a quadratic that opens up. All right, we can get that in standard form. All right, if we do negative b over 2a, that gives us our x coordinate, and then we plug that back into the function, and we get y. Okay, that tells us the location of the vertex. The axis of symmetry, which is this vertical line that goes right down through the middle and splits it into a mirror image on either side, that line is equal to the x value of the vertex because the axis of symmetry goes right through the vertex. So those two pieces are very much related. The y-intercept, which is essentially 0 and whatever c is, that's a point that you will want to know. And a reflection point, when we get to doing an example, I'll talk through what a reflection point is. But we want to find out all these things, and then we can kind of put these pieces on the graph individually, and we get a really good sense of what that particular quadratic graph looks like. So here's an example. Let's sketch this parabola. X squared minus 6x plus 10. Now I have some reminders here to make sure I label the vertex, the axis of symmetry, the y-intercept, etc. The first thing I'm going to find is going to be the vertex. Okay, remember from that previous slide, if I do negative b over 2a, that ends up being the x-coordinate for the vertex. Okay, and it's probably worth defining right here that in this equation, a is 1, b is negative 6, c is 10. Negative b over 2a would be 6 over 2 times 1, which ends up being 3. All right, that tells me right there that the x-coordinate for the vertex is 3. Now if I take 3 and plug it in for x, let's see, 3 squared is 9 minus 18 is negative 9 plus 10. Double check that on your own if you're not convinced, but I believe the vertex is at 3, 1. Okay? So I know the vertex is at 3, 1. This graph, by the way, when I look at A, I see that its width has not been changed and it opens up. All right? Axis of symmetry, again, we've already really taken care of that by the time we get there because of the work we did to find the vertex. It's always the same as the x-coordinate, so the axis of symmetry is right at x equals 3. And our y-intercept equals 10, because that's the value for c. Okay? When you combine that with the fact that I know this graph opens up, and its vertex is at 3, 1, I have a pretty good indication of what its graph is going to look like. Okay? Little bit tricky here to try to give you a good, accurate graph, but I'll do the best I can here. That the vertex is, well, let's see, somewhere right around 3, 1. Okay. Y-intercept is up at about 10. Okay, something like that. And I'd mark my axis of symmetry. Right here. I'm going to label all my different components. Okay. This axis of symmetry was at x equals 3. This vertex was at 3, 1. Okay, and here's when I want to talk about the reflection point. So let's say I've got my y-intercept at 0, 10. Okay, this is the concept of a reflection point. This axis of symmetry is at x equals 3. So if I were to think about the distance from my y-intercept to the axis of symmetry, the x-coordinates differ by 3 units. Okay, which means if I were to go 3 units to the other side over here, okay, which would make the x-coordinate 6, that'll have the same y-coordinate as the point where I started. Okay, so if it's really about thinking about the distance of that point horizontally to the axis of symmetry, and if you go that same distance over on the other side, you'll find another point that's on the graph. All right, here's another example to give it a shot. I'm going to skip over this one because I want to talk about factored form. All right, here's one that we have in factored form. Okay, little bit different deal here. I'm going to do some really similar stuff, but a couple things. I mean, the only real difference that I'm going to do here is that the y-intercept is not easily accessible. So I'm going to use my two factors, set those equal to 0. And as reference points for my graph, I am going to use the x-intercepts. All right? And again, these are the 2 points where the graph crosses the x-axis. I didn't use these points when it was in standard form. I used the y-intercept because that was just the number at the end of the equation. Here, when it's factored, it's in a different form, and that information is not as accessible. So I'm going to use the y-intercepts instead. Now, if I want to find the vertex, because I also don't have the values for a, b, and c, a nice little trick that I can use to get my vertex, if I take my two x-intercepts, -2 and 4, and I average them, my vertex is going to be halfway in between. Okay, so I can just average those two, and my vertex will be at 1. And as always, I'll plug that number back into the equation. 1 plus 2 is 3, and -9. Okay, so there's a point that I will reference on my graph. Not to mention axis of symmetry. It's going to be at x equals 1, because just like before, that x-coordinate matches the vertex. Okay? And really from this, I've got everything that I had before. I could use the concept of a reflection point once again to get a good look at my graph. Okay? But notice the only difference here is that when I have it in factored form, it's very easy to get to the x-intercepts, so that's what I did right here. Okay? I didn't do any of the work to get the y-intercept, which I didn't need because I used the x-intercepts instead. Okay? You could go through, and I'll leave that up to you here on the graph. See if you can take this, okay? And don't forget about that concept of a reflection point. Try that as well. But we would take this information, put it on the graph, and label it just like the one we did before. All right? I'll kind of leave that up to you at this point. This would be a great spot to get some closure here. Take a few minutes, give this a shot, and if you get stuck, just bring it straight to me, and we can take a look over it and see what was giving you trouble. All right? Give that a shot, and we'll talk about it more in class.